Bismillah ar-Rahman ar-Rahim. Welcome back, everyone. Let's talk about the energy and different forms of energy. We take before the potential and the kinetic energy, and we play some games about that with a simulation in potential and kinetic energy. Let's make a simple revision about both of them, and after that, let's take a new lesson for today. At first, we have this question in front of you here: the ability to do work. Ability to do work, that is energy. Okay, without energy, you can't do anything. You don't have force, you can't do work, and like that. Okay, now look over for next question, guys. Now, in this question, you can see that we have pendulum. Okay, we have pendulum, and this pendulum has highest point and lowest point. And this one at motion, of course, this one will move from this position to this position and back again. Okay, and back again like that, and back again like that. So this is the movement of this pendulum. Okay, now my question is, where is the maximum kinetic energy? Which position has maximum kinetic energy? To understand this diagram, we said before we have potential and the kinetic energy. We'll make B symbol for potential energy and the K symbol for kinetic energy. We said that, guys, kinetic energy, which means movement. Okay, movement, any motion, which means kinetic energy. And potential energy, which means the stored energy because of its position. Okay, because of its position. So in the highest point, we have potential energy, here potential energy, and also by another one, here in this point, also we have potential energy because it moves up, but the fastest part, in number 3, we have the maximum kinetic energy. We have maximum kinetic energy. Now look over for this simulation. As you see here, we have this chart which shows you the potential and the kinetic energy. Okay, now when this girl be here, can you see the blue chart? Can you see the blue one? Now, which means we have highest or maximum potential energy. When it moves, now the potential energy will be lower and we have more kinetic energy. Okay, slow down like that, guys. Can you see that? Here we have maximum kinetic energy. Now it moves up again. Potential energy because of its position. When it moves down again, potential energy will get out, and we have kinetic energy here. So again, potential energy and kinetic energy, potential energy, kinetic energy, potential energy, kinetic energy, like that, guys. Like that, guys. They will work opposite with each other all time. Okay, now potential energy again, it's the stored energy because of its position, and the kinetic energy, which means the energy because of its movement or motion. Okay, and today, inshallah, we'll focus on some types of potential energy we have. Okay, let's take a new lesson for today: conservation of energy.
And energy degradation. Law of conservation of energy. In our earlier session, we have learnt about different forms of energy. Now, let us learn about conservation of energy. We have already learnt that energy occurs in different forms, like kinetic energy, potential energy, light energy, heat energy, etc. Generally, the energy transfers between objects. For example, if you hit ball on the ground, energy has transferred from you to the ball, and the ball started moving. The car engine burns the fuel in the car. Thus, fuel transforms from chemical energy to mechanical energy, and car starts moving. According to law of conservation of energy, the energy is neither created nor destroyed, but it transforms from one form to another form. However, according to law of conservation of energy, the energy is neither created nor destroyed, but it transforms from one form to another form.
Okay,
However,
guys, now
the total energy remains
from
constant.
this video you can understand some or a little bit idea about the conservation of energy. Please, this part talk about very important law in our earth, in our universe. Conservation of energy, which means what? It means, guys, the energy, the conservation of energy, which means the energy cannot be, the energy cannot be created or destroyed, or destroyed. Okay, guys? But change form all time. Change form all time. Okay? When I asked you to rub your hand, now you can feel the hot or thermal energy come from your hand. This hot come from where? Come because of you rubbing your hand. Like that. So there no energy come from nothing. We should to have source for all energy, guys. Okay? All time we should to have source for any energy we have in our universe. And in this part here, he will explain and give you a lot of examples in your book. We have another meaning also for the conservation of energy. The amount of energy stay the same. Okay? The amount, make underline please, or write in your copybook, the amount of energy stay at the same. Not destroyed or created, but change form from one to another. For example, we have sunlight here, and the sunlight energy is called solar energy. Okay? Solar energy. This solar energy, the plant will take it, will store it. Now, we have energy stored in the plant. Okay? And this energy here, this is called the solar energy, it converts into chemical energy. Can you see that? Now we have a change of form from solar energy into chemical energy. Now when you eat this plant, now this chemical energy come to your body. You can run, you can jump. Now this kinetic energy, now it change form. You can see that change form from solar energy into chemical energy into kinetic energy, like that. So the energy is still the same amount. Okay, now suppose that we have 100 joule here, it come here 100 joule, maybe this one will take some of this, okay, maybe this plant will take some of this energy, but at the end goes again for you, and like that, guys, like that. So that's the meaning of conservation of energy. The energy will convert, which means a change. Okay, and also, guys, we have another meaning of chemical energy stored in the plant. Any energy stored, it's called potential energy. Okay, potential energy. Any energy stored, it's called potential energy. So we have chemical potential energy stored in the plant. We have another using of this plant. In one day, this plant become tree, right? Become tree. So we can cut this tree and make it wood. And we can burn the wood. When we burn the wood, okay, we have chemical reaction happen. And this chemical reaction, it gets the thermal energy. And this thermal energy will give also light and heat. Okay, give off light. Now we have another change of the energy. From solar energy, let me to change color. Okay, now from solar energy into chemical energy, into thermal energy, into light energy. Change form. That's happen all time. We have a lot of examples. We have millions of examples about the change of form. But at the end, the energy stay the same amount. Conservation of energy. The last example I will explain, maybe this one not familiar for you, nuclear energy. Maybe this is first time to hear about nuclear energy. Nuclear energy come from atom, okay? An atom, it will be the smallest part for any object that we have. Okay, so if you look up for the wood, for example, this wood made up of atoms. Okay, made up of atoms. So these atoms will store the energy inside. And when this one burned, maybe it will turn from nuclear energy or atomic energy into heat and thermal energy. We have another example about nuclear energy. Look over for my screen. That also, guys, another example of nuclear energy. We can use nuclear energy to generate or to create electricity. This is the nuclear factory or nuclear planet. Okay, these also use nuclear energy to create electricity. Okay, we have a lot of examples, of course. In your book, you have another examples. In here, I have some examples here in my screen. Look over. Look over here, guys. Then also potential and kinetic energy now convert. Now it was kinetic, become potential, become kinetic again, like that. Okay, we have a lot of examples here, guys. Now we have chemical energy, become mechanical energy. We have potential energy, come from solar energy, stored in this plant. Sometimes the apple will move down, this kinetic energy. We have another energy stored in this one, chemical energy, when you eat. We have all time it change of form, it change of form, it change of form. Now, here also, guys, in page 64, we have another example. If you look over for the fireworks, these fireworks, okay? Now, these fireworks, when this one moves up like that, and make all of this light and sound on the air like that, okay? Now, we have here chemical energy, and this chemical energy give this one kinetic energy to moves up like that. Okay, this kinetic energy gives sound energy and light energy. Can you see that? We have a change of form from one to another, like that, guys. But at the end, the energy is still the same amount. Okay, still the same amount. Neither created nor destroyed, but a change of form from one to another, like that, guys. Okay, so the amount of energy stay the same. That is the main meaning of the conservation of energy. Okay, guys. Okay, thanks a lot, guys, for all of you. I hope you understand. I hope you enjoy. If you have any question, please ask me on WhatsApp at any time. Thanks a lot. Have a nice time. See you next time, inshallah. Assalamu alaikum.